April 1st, 2026, 6:35 in the evening, Kennedy Space Center, Florida. 4 people climbed into a spacecraft called Integrity. They would travel farther from Earth than any human being had gone since 1970. Farther than the Apollo astronauts. Farther than anyone alive today has ever been. 10 days later, they splashed into the Pacific Ocean off the coast of San Diego. Alive, smiling, fist-bumping Navy divers who cracked open the hatch and said, "Welcome home." By every technical measure, it was a triumph. $93 billion. That is how much it cost to reach this moment. And depending on who you ask, that number is either humanity's greatest investment or the most spectacular financial mismanagement in the history of science. Today, we're going to figure out which one is true. Before we can judge whether Artemis II was worth the price, we need to actually feel what $93 billion means. Because when numbers get this big, our brains just kind of stop processing them. So let's make this real. $93 billion is enough to give every single person in Africa about $3,000 each. That's more than 2 years of average salary in that country. It's enough to build roughly 4,600 fully equipped hospitals. It would fund the entire United Nations operating budget for about 12 years. You could pay 4 million teachers' salaries for an entire year with that money. Now, I'm not saying NASA should have done any of those things. That's a different argument, and we'll get to it. But I want you to hold that number in your chest as we go through this, because it's easy to throw around billions without ever really confronting what a billion actually is. 1 billion seconds ago, it was 1994. Bill Clinton was president. Toy Story hadn't come out yet. 93 billion seconds ago, human beings hadn't developed agriculture yet. Okay, so where did it all go? Here's the actual breakdown, according to government audits. NASA's Office of Inspector General, in a 2021 audit, later updated in 2024, found that spending on just 3 components of Artemis had already crossed $55 billion before Artemis II ever launched. The Space Launch System rocket, over $23 billion in development costs and roughly $2 billion per flight. The Orion spacecraft and its European service module, approximately $1.3 billion per mission. Exploration ground systems, the launch pad, the crawler, the vehicle assembly building upgrades, another $658 million. Plus human landing system development, the landers that will eventually take astronauts to the surface, $1.7 billion and counting. The full $93 billion figure covers everything from 2011 through fiscal year 2025. Spacecraft, rockets, staff, testing, infrastructure, delays, cost overruns, and yes, delays upon delays upon delays. The Trump administration's own budget documents from May 2025 described SLS as grossly expensive and noted the program had come in 140% over its original budget. That's not a critic. That's not a rival space company. That is the executive branch of the same government that runs NASA, calling its own program grossly expensive. We're going to come back to why they kept funding it anyway. The answer is more interesting and more troubling than you might expect. But first, let's be fair to the mission itself. Because if we're going to evaluate the price tag, we need to be honest about what was delivered. And what was delivered was genuinely remarkable. At 6:35 p.m. Eastern Time, with 8.8 million pounds of thrust, the SLS rocket lifted Wiseman, Glover, Koch, and Hansen off the ground with what NASA called a smooth countdown, and delivered them to orbit with pinpoint accuracy. That's not marketing language. That's actually what happened. In spaceflight, where a single bad valve can cost lives, a smooth countdown matters. In the first 24 hours, the crew ran comprehensive checks of every critical system aboard Integrity. Life support, navigation, communications, the spacecraft's ability to be manually flown by the crew. NASA also deployed 4 CubeSats from international partners into Earth orbit. One small detail the press barely covered. Mission controllers on the ground actually canceled the first outbound trajectory correction burn. Because Integrity's path to the moon was so accurate, the adjustment wasn't needed. On Monday, April 6th, at 12:56 p.m. Central Time, the Artemis II crew became the humans who had traveled farthest from Earth in all of human history. 252,756 miles from home. That broke a record held since 1970 by the Apollo 13 crew, who didn't even want to be that far out. They were running from a crippled spacecraft trying to get back alive. Orion came within 4,067 miles of the lunar surface, about the distance from New York to Los Angeles, traveling at nearly 61,000 miles per hour relative to Earth. During their lunar flyby, the crew observed things no human eyes had ever directly seen. Lunar features on the far side, at angles and illumination conditions impossible to capture any other way. They photographed craters, suggested names for two unnamed ones. They called one Integrity, after their spacecraft, and studied a rare solar eclipse, watching the sun disappear behind the darkened moon and seeing its corona glow around the lunar edge. They also watched for meteoroid impacts on the lunar surface. Real-time data. Information that will inform how future base camps protect their inhabitants. Meanwhile, the crew participated in medical experiments. The Avatar investigation studied how human tissue responds to the deep space radiation environment. Radiation levels dramatically higher than what astronauts experience on the International Space Station, which is shielded by Earth's magnetic field. That data matters. Before you send people to live on the moon for weeks, you need to know what deep space radiation does to muscle tissue, to bone density, to the immune system. You cannot get that data in a simulator. You cannot get it in low Earth orbit. You had to go. On April 10th, Integrity screamed back into Earth's atmosphere at 24,664 miles per hour, comparable to Apollo-era lunar returns, and splashed down at 5:07 p.m. Pacific Time off the coast of San Diego. Commander Reed Wiseman's words in the capsule to his crew, "Victor, Christina, Jeremy, we are bonded forever. And no one down here is ever going to know what the four of us just went through. And it was the most special thing that will ever happen in my life." 694,481 miles, 10 days, 4 humans. Every critical system validated. By any technical standard, that mission succeeded. So why are we still asking if it was worth it? Here is where the story gets genuinely uncomfortable. And I want to take my time with this, because it's more complicated than NASA bad, SpaceX good. That framing is too simple and frankly, a little dishonest. But the facts are what the facts are. The rocket that ate NASA's budget. The Space Launch System has been in development since 2011, 15 years. Its original launch date was December 2016. It first flew in November 2022, 6 years late. And the SLS isn't some cutting-edge technology. It is built around space shuttle engines, RS-25 engines, that were designed in the 1970s. It uses solid rocket boosters that are direct descendants of shuttle boosters. It is, by design, throwaway. Every piece burns up or falls into the ocean after every single launch. The development cost has now crossed $23 billion. Each operational flight costs somewhere between $2 and $4 billion, depending on what you count. The 2021 OIG audit put it at $4.1 billion per launch, all in. And here's the Government Accountability Office's assessment. NASA's own senior officials acknowledged the SLS was unsustainable at current cost levels. That was 2018, 8 years ago. And the program continued, because canceling it would have been politically explosive. The 26 schedule slips. This is an opinion, This is documented. The SLS has slipped its launch target more than 26 times across its development history. December 2016 became 2018, became 2019, became 2020, became 2021, became November 2022 for the first uncrewed test. For Artemis II specifically, the story is almost comical if it weren't so expensive. The original launch target was late 2024. That slipped to September 2025, then to early 2026. Then a wet dress rehearsal in February found a liquid hydrogen leak. Then, after fixing that, a helium flow issue in the upper stage forced a complete rollback to the vehicle assembly building. 2 launch scrubs in a row, millions of dollars in additional costs. Launch finally happened April 1st, after the program had already burned through tens of billions in development. Every month of schedule slippage means continued workforce costs, facility operating expenses, and the cost of hardware just sitting there waiting. Meanwhile, on the other side of Florida, SpaceX is catching a 70-meter rocket booster, the equivalent of a 20-story building, out of the sky, with robotic arms, after it launches to space and comes back down. Starship is the largest, most powerful rocket ever built. It's designed to be fully reusable. The goal is to fly the same hardware dozens of times, just like an airplane. SpaceX has been iterating rapidly, learning from each test and gradually proving out the system. Early Starship test flights cost roughly $100 million each. Operational costs per launch are projected to drop dramatically as reusability matures. Elon Musk's stated target is eventually $10 million per flight, though even conservative independent analysts think operational costs could ultimately be 10 to 20 times cheaper than SLS per mission. Now here's the part of this story that most coverage has completely missed, because it makes everyone involved look slightly absurd. NASA is planning to use Starship to actually land the astronauts on the moon. The $4 billion SLS launches the crew. It delivers them to lunar orbit. Then, they transfer to a SpaceX Starship, which was launched separately and which carries them down to the lunar surface. SLS gets you to the parking lot. SpaceX drives you to the destination. So NASA built an expensive government rocket to serve as a taxi to the taxi. And the government taxi costs 40 times what the commercial taxi might eventually cost. In May 2025, the Trump administration's FY 2026 budget proposal called for canceling SLS and Orion after Artemis II, citing that $4 billion per launch price. Congress pushed back. The One Big Beautiful Bill Act ultimately funded 2 additional SLS missions, Artemis IV and V. But the writing is on the wall. SLS's days are numbered. In March 2026, just weeks before Artemis II launched, NASA announced it was also canceling the Lunar Gateway, the planned space station that was supposed to orbit the moon and serve as a hub for surface missions. The Gateway was scrapped. $2.6 billion in funding for it is now being redirected to other priorities. There's one more layer here, and it involves Boeing, the prime contractor for the SLS core stage. A 2018 NASA OIG report found that between 2013 and 2017, Boeing received approximately $234 million of a possible $262 million in performance award fees, during a period when the program was years behind schedule and hundreds of millions over budget. In other words, the contractor was getting paid for performance it wasn't delivering, and NASA's oversight was described as slop. Here's the question that doesn't get asked enough. If senior NASA officials knew the SLS was unsustainable in 2018, if the GAO said it was unsustainable, if the Trump administration called it grossly expensive in 2025, why did it keep going? The answer is jobs. Not in a cynical way, in a very real, very human way. The Artemis program employs people in nearly every U.S. state. Boeing workers building the core stage in New Orleans, Northrop Grumman technicians on the solid rocket boosters in Utah, Aerojet Rocketdyne engineers on the RS-25 engines in Sacramento, Lockheed Martin building Orion in Colorado and Florida. Thousands of contractors, tens of thousands of indirect jobs. Every congressional district that touches Artemis has a representative who will fight hard to keep those contracts alive. Canceling SLS doesn't just mean switching to a cheaper rocket. It means closing facilities, laying off workers, and making enemies in Congress whose votes you need for everything else. This is called pork barrel politics, and NASA has been navigating it since Apollo. The SLS is sometimes called the Senate Launch System because it was essentially designed by congressional mandate. In 2010, Congress passed the NASA Authorization Act, which mandated the development of a new heavy-lift rocket using shuttle-derived components. That mandate was partly about capability, but it was also about protecting the shuttle workforce and contractor base. Senator Richard Shelby of Alabama was famously protective of SLS for years because NASA's Marshall Space Flight Center, which manages the SLS program, is in Huntsville, Alabama. This is not a conspiracy. It's just how large government programs work. And it's worth knowing because it explains why rational arguments about cost efficiency don't automatically change the program. What is changing the program, finally, is the emergence of Starship as a credible alternative. When you can point to a rocket that catches itself out of the sky and costs a fraction of the price, the political math starts to shift. Okay, we've gone hard on the problems. Now, let's be genuinely fair, because the critics of Artemis aren't always being honest either. Point 1. The "what else could we do with $93 billion" argument is flawed. This is the most emotionally powerful argument against Artemis, and it's also the most logically flawed. When people say, we could have built hospitals with that money, they're assuming the political alternative to Artemis spending is healthcare. It isn't. Federal budget decisions don't work like a household budget. The realistic alternative to Artemis funding is not a $93 billion healthcare windfall. It's some mix of deficit reduction, other discretionary spending, or simply tax cuts. Moreover, NASA's entire annual budget is roughly $25 billion, about 0.3% of federal spending. It is not competing with Medicare. The U.S. defense budget alone is about $900 billion. Point 2. NASA money doesn't disappear into space. When NASA writes a $2 billion check, that money pays American workers, engineers, machinists, scientists, university researchers. It creates supply chains. It funds companies that then go on to develop technology for the private sector. The Apollo program's technology spin-offs included memory foam, water purification systems, scratch-resistant lenses, CAT scanners, and foundational work in computer miniaturization. Not every dollar of that value was direct. Some of it compounds for decades. Artemis is already generating economic activity, not just at Kennedy Space Center, but across the supply chain. The Planetary Society calculated that NASA's final fiscal year 2026 budget, including supplemental funding, represented the largest NASA budget since 1998. That's a significant economic footprint. Point 3. The geopolitical stakes are real. China has announced plans to land taikonauts on the moon before 2030. China and Russia signed a joint framework for lunar exploration. The lunar South Pole, where water ice exists in permanently shadowed craters, is the strategic real estate of the 21st century. Water ice can be converted to hydrogen and oxygen, rocket fuel. Whoever builds infrastructure at the lunar South Pole first gains an enormous logistical advantage for all future deep space operations. This isn't science fiction. Scientists have confirmed water ice exists at the lunar South Pole. The question is, who extracts it first, and who controls the rules of that process? Sitting out isn't an option if American leadership in space actually matters, and there's a very strong bipartisan consensus that it does. Point 4. Artemis II bought something irreplaceable. The mission's data haul is genuinely significant. The Orion spacecraft's performance in the deep space radiation environment beyond Earth's magnetic field was validated. Life support systems held. Navigation proved accurate enough to cancel a trajectory correction burn. Manual piloting tests were completed. Human biomedical data in real deep space was collected. None of this can be simulated. You cannot test a heat shield in a computer model and then bet 4 people's lives on the result. You have to go. Artemis II was that test. And the heat shield data is particularly important because after Artemis I's uncrewed flight in 2022, engineers found unexpected erosion in the ablative material, protecting re-entry from 24,000 miles per hour atmospheric friction. That's why Artemis II flew a steeper, direct entry trajectory instead of the planned skip re-entry. NASA changed the re-entry profile to limit heating duration while they continue investigating the heat shield material. That change may seem small, but it's the kind of decision that keeps crews alive. Point 5. The commercial space sector exists because of NASA. SpaceX, the company everyone wants to replace NASA, exists in large part because of NASA. In the early days of Falcon 9, a $400 million NASA Commercial Orbital Transportation Services contract was critical to SpaceX's survival. Subsequent commercial crew and commercial resupply contracts provided billions in stable revenue while SpaceX developed Starship. NASA seeded the commercial space industry. Artemis is now doing the same for the next generation, particularly through the Human Landing System contracts that have funded both SpaceX's Starship HLS and Blue Origin's Blue Moon. The competitive pressure between those two has driven both companies to move faster than either would have alone.
All right, you stayed with me for 23 minutes. You deserve a straight answer. Was Artemis II worth $93 billion? Here's what the evidence actually supports, broken down honestly. The mission itself. Yes, a crewed deep space test flight was necessary. You cannot skip this step. The data collected on Orion systems, on human physiology and deep space radiation, on manual spacecraft handling, is genuinely essential before you bet lives on a moon landing. The crew delivered. The systems worked. The record was broken. The SLS rocket. Contested, and probably not in the long run. A $4 billion throwaway rocket is hard to justify when a reusable alternative is in development. The SLS is a political artifact as much as an engineering one. It has kept jobs alive and maintained an industrial base. Those are real things, but its long-term cost structure is not sustainable, as NASA's own officials have admitted. The Trump administration's push to phase it out after Artemis 3 and 5 may prove to be the right call. The program management and oversight. No. 15 years of development, 26 schedule slips, 140% cost overruns. Contractors paid for performance they didn't deliver. The Government Accountability Office warning about sustainability in 2018 that nobody acted on until budget pressure forced the issue in 2025. That is not how you run a $93 billion program. The vision. Tentatively, yes. A permanent human presence on the moon, with water ice extraction and a path to Mars, that is a genuinely worthwhile ambition. Whether the current trajectory gets us there, at an acceptable cost, on a realistic timeline, remains deeply uncertain. An independent safety panel is already warning that Artemis IV's 2028 moon landing target may be unrealistic. The geopolitical argument. Yes, China is coming. The lunar South Pole is strategic. Ceding that ground to a competitor would be a decision with consequences that outlast any particular administration. Here's the honest bottom line. $93 billion bought something real, just not always efficiently and not always wisely. The mission was worth doing. The way it was structured cost more than it needed to. And the decisions being made right now about commercial landers, about SLS's future, about the lunar base, will determine whether Artemis II was a bridge to something extraordinary or an extraordinarily expensive warm-up act that didn't quite lead where it promised. We're living in the chapter before the verdict. The moon isn't going anywhere. But whether humanity, and specifically America, builds something lasting there depends on choices that haven't been made yet.
No one down here is ever going to know what the 4 crew just went through. That's the thing about exploration. The cost is visible. It's in the audit reports and the budget hearings and the news articles. But the experience, the actual meaning of staring back at a marble 252,000 miles away and knowing you're the farthest humans alive, that doesn't fit in a spreadsheet. Whether that's worth $93 billion is a question each of us has to answer for ourselves. But before you answer, remember this. Every major human infrastructure project in history looked wasteful to someone at the time. The Transcontinental Railroad, the Interstate Highway System, the Internet, which started as a DARPA project almost nobody thought had commercial value. The moon might be the next one of those. Or it might not. The only way to find out is to go. Drop your verdict in the comments. Was Artemis II worth it? And what should NASA do differently for Artemis IV?